Okay, let's start. We are of course trying to stream this and record it, and if I try to start writing there or moving over there, then you should shout and say you are not allowed to use the whiteboard today, because they only have this one. The topic for today is testing, and we will in most talk of the time present a tool called JUnit. Have any one of you used it? Oh, a few. What is testing? Have you been testing your programs? I guess you have. Not maybe a thorough testing, but I think you have tested your programs. Testing, the process of executing a program with the intent of finding errors. You have developed your code, and before you are submitting it, I guess that you go through something like this. You run it a few times to see that it works. Nowadays, in a company, they are often working in teams of about 7 people, and I would say 2 of them are testers nowadays. So in a team, you have 1 leader, project leader, and you have 4 developers and 2 testers. And the developers are developing their code, and when they are done with it, they give it to the testers, and the testers run it and make sure that it fulfills all the criteria. I will talk about testing in general a bit for a while, and then we will move on to this tool called JUnit that can be used to test Java programs. First of all, a bit of vocabulary here. When we are talking about Java programs or systems, we have the whole system that contains a number of subsystems, and the subsystem contains components, and the components contains classes. This is the hierarchy that we are using when we are talking about different parts of a program. Subsystem components, and a component contains 5 or 10, 5 classes, something like this. Different types of testing. Component or unit testing. You have developed your class here, and then you're testing it basically. This is the first type of testing, and it's often the programmers themselves that take care of the component or unit testing. Then we have integration testing. We take a few components, put them together, and we see if they are working. If they together solve their task and fulfill their requirements. That's called integration testing. We have something called regression testing. Once we have made a change, we have a software base here, we have our system, and then a customer asks us to implement a new feature. Then we are implementing the new feature. We are testing this new feature, but then we must test the entire system one more time to make sure that this update, this maintenance didn't change any vital things in the system. So every time we make an update or change of the code, we have to retest everything, and this is called regression testing. They are not doing all things. They are picking a number of things that are most crucial that they are working, and then they are testing them one more time. Performance testing. This is a specific type of testing. You are tormenting your system. Your system is designed to handle 1,000 transactions each second, for example. Then you are trying to use 10,000 transaction just to see how it behaves. What is a reasonable behavior when we are pushing it like this? Well, if it was designed for 1,000 transactions a second and we are testing it with 10,000 or 5,000, then we can expect it to be slow. That is okay. Crash is not okay. So performance testing is often to see if you have acceptable behavior when we are pushing the limits a bit. And being a bit slow is okay, but losing a transaction is not okay in this case. Release testing and acceptance testing, alpha testing and beta testing. We have a complete system here. We are testing it in-house in our company, but we are basically trying to make sure that everything we promised, all the requirements in the requirement specification, is fulfilled. And then we take our software and we give it to our customers, and they are testing it. The secretaries or the people who are supposed to use it in the future are the one testing it. A small group of them are testing them. So these are different types of testing. Any questions about testing? Different types of testing? Yes?
The performance test, is that a kind of stress test?
Yeah, pushing the limit, yeah. Yeah, stress test, very much the same. We talk about independent black box and white box testing. Developers have a tendency to write tests that fits their implementation, not because they are lazy or evil. If you are developing a queue, maybe some of you are developing a queue, and you should test it, then it turns out that we have a tendency to we know about the implementation, so we are biased when it comes to testing it. So we are testing it in the way that we think it should work, not necessarily how it was specified. So a lot of experiments has been done, and it shows that it's much better to have an independent test team. One group is developing and another group is testing it. The test team, they know, they have a specification that this component should have the following properties, and they go through all these properties. So better chance to find logical errors if you do this, but of course it is more costly. The one who have developed the system, he is familiar with it, he could rather easily test it. So it takes a bit more time to have someone else to come and test it, but the advantage is we find more errors, and that's the main goal here. Black box testing. We are testing a component without knowing how it's implemented. We have a specification saying that the queue should have the following methods, they should do the following things, and we are testing that the methods fulfill these criteria. We don't know anything about the code, where it's array-based or linked or whatever. We are just testing the interface in some way. This is called black box testing. White box testing is when the tester knows about the source code and tries to make sure that all parts of the source code are reached or touched by the tests. When we are doing black box testing, we might have a scenario where we have some parameter, we have an if statement saying if n less than 0, then do this. And it might be that we are never touching this if part. However, white box testing, they try to design their test in such a way, they know about the code, and they try to make the test in such a way that every statement in the code should be a part of the test. They try to reach all parts of the code. Once again, this is impossible for a larger system. No one knows about, well, take a system with 1 million lines of code, no one knows about the details of this system. So it only works for smaller systems, the white box testing. This is the only doable approach for larger systems. We can just verify or try to verify that the system fulfills its criteria. That's all we can do. We cannot make sure that every branch and if statement is tested in our test. This is the negative result. In most cases, we can never verify that our program is correct. Let's take one of your assignments. Let's take you were implementing a stack in your previous course. You remember it? Did it work? Can you guarantee that it works in all cases? No. If you want to guarantee that it works in all cases, you will never stop testing it. You should basically test every user scenario, and there are an infinite number of different combinations of pop and peek and push. So in general, this is impossible. We can find error, but we cannot prove that the program is correct. This is the downside. There are some theoretical approaches where you can actually prove that in any execution this type of error will never happen. You can prove it mathematically. It is extremely time consuming, and it's hardly ever used. There are a few systems that are doing this approach. Safety system for the nuclear power station or something like this. They do theoretical proofs of some part of their code to show that this error will never, it cannot happen in this system. So in practice, we cannot guarantee that our system is working. We can, so if we cannot guarantee that our system is without any errors, why do we test then? Well, basically, the more we test, the more confidence we start to have with the system. Let's go back to the stack. You implemented your stack, and you pushed the number and popped, and you tested it in different ways. After a while, you start to believe that this one is actually working. Did you reach this point? Yeah. After a bit of testing, we actually start to think that it works. So we are testing to build confidence in the system. That is the purpose of testing. After a while, we start to think that this one works. We have confidence in it. Reasons for testing. Well, of course, we would like to find errors. And here I mentioned 3 different types of errors. Well, the system crashes. In your case, it will be an exception. And these are red printouts that you all have seen. And that is not good, of course. Incorrect computations. We might have that the program is running fine, but the result is not correct. That's also a problem. Data corruption. What do I mean by data corruption?
The loss of data while processing.
Yeah, we are asking the bank, give me the current account status. And as a side effect of this question, we are changing the account. Then we have corrupted the data. We have a side effect that changes the data in a way that was not expected. So the system works okay. When I do this question, I'm asking what is the current status of my bank account. I might get the correct result, but as a side effect, something might be changed in this one. This is called data corruption. And also, so the 2 reasons for testing is, of course, try to find as many errors as possible, but also convince ourselves that the system meets its requirements. We are a company here, and we should sell this product to someone else. We would like to convince ourselves that we are not selling crap. So it is also to build confidence in what we are doing. When should testing take place? Always was one answer here. You? Yeah, always. The basic rule is as soon as possible. Do you remember from the previous course that I talked about the process? Requirements, implementation, and then we go through. The old approach was after system development but before release. We saw the development process as a sequence when we are doing different stages, and in the end we were testing it. It turns out to be very costly. We have been developing the system for 5 months, and then we realize it's not working. And when we try to fix it, we have realized that something was wrong already in the beginning. So we have to basically restart from scratch. This is the recommended approach. As soon as possible, when someone has implemented a method or a class, they should have a first test of it. And as soon as 2 components are ready, we should try to put them together and see if they can interact correctly with each other. There is one approach called extreme programming. They say before implementation. What on earth do they mean?
Like before even we finish program.
Before implementation, they say we should start to think about testing. We can already decide that this component should be tested in this way. We have already made our test program. Then we start to implement. More goal-directed. As a programmer, if I gave you a test program, I said, you are done with your queue implementation when this program doesn't find any error. Then you have a goal. I should implement a queue that passes this particular test. And you know that you know exactly when you're done. You can run your program in this test environment and it doesn't find any errors. Well, then you're done and you can go on to the next task. So some people say that this is the way to do it. You should actually start by deciding how things should be tested. And then once you have decided upon them, then you should test. Then you should implement it, and you shouldn't spend any more time on your implementation. The only goal is to pass this test. Then you're done. There are people promoting this idea. People often say, yes, it works fine for a queue or a stack. It doesn't work for a more complex system. We cannot do a proper test in advance for this one. But this is the one I would like to promote to you. It should be done as soon as possible. So, but I think you are doing this already. You are asked to implement a class, and you are implementing one method in this class. What are you doing once you have implemented a method? What are you doing then? You have your main program and you're testing this method to see that it works. So I think most of us is, at least to some extent, doing this thing. We are implementing it and then we are running it to see that it works properly. And this is the idea. From now on, we will mostly talk about the testing that you will be supposed to do in the assignment, and it is called components or unit testing. Basically, we mean by a unit something that can be tested in isolation. It can be a few classes that solves a task and we can test them. They are not depending on the entire system. They are a small set of classes that solve some problem or provide some feature, and we can test it by itself without connecting it to the entire system. This is a component. Typically, data structures, algorithms, well, anything that is a standalone unit can be tested by itself. And when we are doing this type of testing, as a programmer, we would like to convince ourselves that what I've done this last 2 days, that it's actually working correctly. So convince ourselves that the component works properly by itself. When are we doing this testing? During or directly after implementation. You have implemented your queue, then you're testing it directly afterwards to make sure that it fulfills all the criteria. And it is often the programmers themselves who do this type of testing. And this is white box testing. The programmers knows about the code that they are testing, and they can try to write their test in such a way that every statement in the code is touched by this test. So this is what we are focusing on today. I think many of you will take a course in your second year called testing. It will be an entire course about testing. Then you will learn a bit much more how we are testing larger subsystems. How do you test a larger subsystem containing 5 components? Are you waiting until all 5 components are done and then you test it? Or do we have any other option? Well, you have other options. You can insert a fake component. Stub is it called. A stub is it has the same interface as the component that we're waiting for, but it always return 1 or something like this. It's a placeholder for the correct component. So you are developing a subsystem here, then you start with one component and then you have stubs for the other ones that just simulates their behavior while we are waiting for them, and then we are adding the new components one at a time. But that's system testing, and it will be a topic of our upcoming course. How do we test? Test case design. Let's take our queue. The queue exercise, we are giving you an interface. So these are the things that we expect from a queue. You should, of course, test all of them. All the methods in the queue interface should work. And how do you test them? Well, for each method, for each feature that we're interested in testing, we find a set of input data and we find the corresponding output data. And then we compare them. And then we compare the expected output data with the one that we are actually receiving from our component. Assume a method just called multiplication. It takes A and B and it returns A times B. How would you test that one? You should have a number of A and B's, and you should send them to this one and you should get the result, and you should compare the result with what you know is the correct result. So testing requires input data, a number of A and B's, and that we know the exact result. That's the O. And then we are comparing the execution result with the output, with the expected output. So what we are saying here is that you want to test a number of features, then you must find suitable input data to test this specific feature. You must know what is the expected result for this input data, and then you are comparing the actual result with the expected result. The main idea here is that there is no point in testing something if you don't know what the result should be. If you have a function that takes 2 parameters, A and B, and you don't know what it's doing, how could you test it? You must know what is the expected output from it. Yeah?
When we're testing, should we start with a favorable input or directly with an unfavorable?
You should, I will come to this later on, but you should test everything. Both of them. Standard cases, we will talk about standard cases and extreme cases. Standard cases is 7 times 8. An extreme case might be 0 times 8, since people might have an algorithm for computing multiplication that can't handle 0 or negative numbers. This triple, in order to test the multiplication method, we should have the following inputs and we are expecting the following results. These are the things, this is called a test plan for the multiplication method. Known input, known output, and if we should also think that if we are doing these tests and we receive this output, well, then this one is working properly. The input data, this is terminology related to text testing is called a fixture. This is the input data. And you will see when you do your testing that producing the input data, the fixture, is a bit time consuming. You have to build up a number of queues or something like this. You have an automatic mechanism to generate random queues or something like this. Sorting. I will in the next slide present a method called sort that takes an input array and it should sort it. How would you test this one? A single method that sorts an array. You should of course provide a number of different arrays and you should verify that it's sorted afterwards. What arrays would you pick?
We pick a small array and then a big array with like millions of items.
Yeah, we should definitely test the performance to see that it doesn't crash when it's larger. So we should have at least one test containing a huge array.
We should also start from one that's already ordered and one that's like the opposite order.
Yeah. And I would also, your idea is correct. This was my first suggestion. We start with an empty array, just to make sure that the program doesn't crash. The implementer, this is a typical thing that it's easy to forget as a programmer. You don't think about the case when we have an empty array. You are starting by picking out the first element, and in that case, using this input, it will crash. We can have a list with only one element to make sure that it doesn't change it in any way. Then we have a few standard cases, and then we have a very large array. But I agree with you, we should also have a case where it's already sorted. We should make sure that it doesn't change that one, or maybe in reverse order, and then it can handle this one. But the general idea is that the standard cases, we don't need many of them. If it can sort an array of size 10 with random values, it can probably sort one of size 20 of random values as well. So most problems, it's also been a lot of research in this area. Where do we have a lot of errors? It turns out that the errors shows up in extreme values. The programmer, he thinks about the standard cases. He never makes an error in the standard cases. However, he might forget this case, or he might have a very strange algorithm that totally breaks down for larger input arrays. So a few standard cases and extreme cases. This is it. Yeah.
As I recall, JUnit often takes time to build, maybe not to run the test, but to build the test.
Yeah, they are. Well, it depends on what your input is, but sometimes building the fixture is more time consuming than just doing the actual test.
I mean, when running the test.
You mean it's slow in some sense?
Yeah, I mean the execution is slow compared to just running as standard. I mean building the JUnit.
No, I wouldn't say that. I wouldn't say that it's very slow, but if you want to test a more complex thing, then quite often you have to build up this complex thing in a certain state. And then you are testing that in this particular state, when I do this method call, I get this response. So constructing the scenario where we're actually doing the testing is sometimes time consuming, but that was not what you meant. You meant that it was slow in general.
I meant when running, yeah.
Yeah, it shouldn't be. It shouldn't be.
I have a question.
Yeah.
What about the no element? Is the program going to be crashed if we put a no element there? The sorting.
This one.
Yeah.
I think if you have a method that looks like this, it says it will sort an array. It should be able to handle this one. It should return it untouched. It should say if the size of the length of the array is 0 or 1, it should just return the array unchanged.
No, I mean if we have a no element inside a large array, will it crash?
Then we must, this is a simplified case, I'm saying sort an array. All methods have certain preconditions. For example, if you should read the documentation for a sorting method like this, it should probably say that we are expecting that the array is full. I don't know any sorting routine that can handle an array where every second element is empty or something like this. It makes it tricky. So a basic assumption is probably that the array is full. So in general, test all the extreme cases. Test a few, not many standard cases. Test scalability or performance by a large case. Yeah.
Issue regarding the sorting method. Would you try also to test another type instead of integer, try to insert a character or something like that?
But if the method looks like this, it takes an integer array. Well, you cannot test it with a string array. You will get a compilation error. Yeah. Don't be over ambitious. You will be asked to test your queue implementation, and then we are expecting you to test all the methods or all the public methods or something like this. You don't need 20 tests for each of them. You need a few tests only. You should test that, for example, it throws an exception when we try to dequeue an empty queue. You should add one element and see that when we are dequeuing it, it is this particular element. And then, just to make sure that your implementation is correct, I would, in the queue case, I would add 1 million elements to the queue and then pick them out to see that it can handle 1 million element. Yeah, and things like this. So don't overdo it. Extreme cases, a few standard cases, that's it. White box testing. A minimum, I would say, that you are testing your queue implementation. Of course, you should test all the methods. You cannot have, you cannot say that you have properly tested a component if you haven't if you haven't tested one of the methods in this class. Make sure that every statement is tested. This is, for the queue, I would say this is a realistic goal. It should be possible to have different user scenarios for the queue, that every part of your implementation is touched by it in some sense. So I say this is where you should aim for. And you will see that the actual test, add a few elements to the queue and put them out. Writing this test is not time consuming. Building up some kind of infrastructure that generates a random queue is a bit more time consuming. So quite often, or a large portion of the time in testing is to come up with fixture input data that is suitable. So this is what we are suggesting and what the literature related to testing suggests. Implement a method and test it. I think you have done something like this. We would only like you to do this testing a bit more thoroughly when you are testing it, and you shouldn't throw it away, because I guess you're doing this. You have your main method and you're implementing a method, and then you're testing this method. And then you think, okay, method M1 is okay, and then you're removing your code. And then you implement the next method, and then you do this. Basically, it should be possible to create a test case that you can at any time run this one to make sure that your queue is working properly. That's why we have separate test programs. In the same way as we are storing our classes, we are storing our corresponding test cases. If you take a look at more professional developed software, they have a package infrastructure for the program and they have the corresponding package infrastructure for the tests. So there are basically two programs or two file structures, one for the program and one for the test code with it. And you are implementing your class and you are submitting it to the SVN system and you are submitting your test to the SVN system. They come hand in hand. What about the break? Let's take a 5-minute break. Yep. What? Oops. Please tell me if it starts to get too cold.
Så skulle lämna in ett Java-docsen för klasserna link Q och Q.
Vad säger du? Vi skulle lämna in?
Classes. Men det är en interface eller?
Oh, by the classes. Ja.
Men det är fortfarande en interface.
Ja. Vänta då. Vad var uppgiften? Skulle ni inte dokumentera det med Java Docs?
Jo, det är väl rätt rimligt att dokumentera interfacen, men att det står klasser så jag behöver lite...
Nej, men alltså, vi vill ha HTML-koden för de där två klasserna. Ja. Har du provat att använda Java Doc?
Ja.
Den genererar ju jättemånga sidor. Vi vill inte ha alla dem, vi vill bara ha 2 HTML-sidor. Ja. Har vi några distansstudenter så står jag nu framför Slack här. Så om ni har någon fråga så kan ni skriva in den i Slack. Okay, let's start. Okay, please sit down. Okay, let's move on. The reminder of this lecture, we will talk about a tool called JUnit, and it's a testing tool. It is designed to simplify the testing of Java components, that means smaller parts of a Java program. It has many advantages. It's for free, and it's thoroughly documented, and it's not only supported by Eclipse, it's also included in newer versions of Eclipse, and you all have newer versions. They are using a few fancy features called annotations and reflection. That means if you really want to understand what's going on during the tests, it's a bit tricky, but it's easy to start using and very useful when you're using Eclipse, since it's already Eclipse is prepared for it. Last year, 2017, I think, they released a new version, JUnit 5, and we will use the new version. So make sure that you have the latest version. Did you all install a new version of Eclipse when you started the Java 1 course? Oxygen or something, what is it called? Yeah, then it is included in this one. Only if you start to have older versions of Eclipse, then you should worry. Also, it requires you to use Java 1.8. But if you're trying to run it without Java 1.8 or 9, it will complain. You will see that in Eclipse, Eclipse has plenty of support. Basically, you write your test and then you right-click and say, not run as application, but run as JUnit test, and it will run. First example, I have a method here, multiplication. It takes A and B, and it should of course return A times B, but I do it in a strange way here. I do a recursive solution to compute multiplication. Does it make any sense to you? We are multiplying A and B, and we are requiring that the second argument B should be non-negative. So if B is less than 0, then we throw an exception. If B equals 0, then we know that anything multiplied with 0 is 0. Otherwise, we say that the result is A plus A multiplied with B minus 1. So this starts the recursive call. Does it make sense? Basically, so this is an odd implementation of how to multiply A and B, recursive approach. My idea here is that we are testing a few extreme cases, I call them here, multiply by 0 and 1. A few standard cases, a somewhat larger case, and then we test that it throws an exception. So this is the test idea. Does it make sense? Extreme cases, large case. This one throws an exception, so we should verify that it actually throws an exception when we have a negative B value. This is the test for this one. It is a Java program. It is a public class, my test, and then we have the test method here that is testing my multiplication method, my static multiplication method. So here I am testing the multiplication, the extreme cases. I'm checking that 10 times 0 is 0, so I'm performing the multiplication here, and this is the known result, 0. assert equals 10 equals 10 times 1, and I have a number of these assert equals. These are a part of the tool. These are the methods that we are using. And they often take, well, they're called assert equals, assert same, assert true. They make different assertion, and when we are using the equals one, of course, this result should be equal to this result. So here I'm performing 3 tests of the multiplication, and when I run this program, if any one of these goes wrong, it will say you had an error in this line. We were expecting 0, but the output was 22 or something like this. So it is rather convenient to do the tests. We are using these assert methods for our different tests. We are testing that this large number is equal to this multiplication. And when we are running it, I will show it later on, Eclipse will change a bit of its view and switch to the JUnit view, and it will say, out of 5 tests, all of them were okay, maybe. Or out of 5 tests, 4 of them was okay. In the 4th one, we had an error on this line. So it will give you a rather handy. We are, of course, using a library here, and we need to do certain imports. They should be available in your Eclipse installation. So you should be able to take my test program and just install it and run it at home. We are here, we are making these assert methods available, and up here with this particular import, we are making this annotation available. You will see that this is an ordinary Java class, but some methods are annotated with tests. These are the test methods. Then we might have other methods that are used for building up the fixture or something like this. But the tool will only execute the methods annotated with test. Yeah, so basically a JUnit test contains ordinary Java code where we are making use of these assert methods, and some of the methods are tagged with a specific tags indicating how they should be executed during the test. So we have a few required imports. Each method in our test class is called a test case, and they must be annotated with test. And you will see that when you are running this code, this will be the ones. If you have 5 methods annotated with test, it will say that it was running 5 tests and 4 of them was okay and 1 failed. We have a number of assert methods, and they are often of 2 different types. Here we are saying that this result, we are performing an operation here on our class, and we say the result is we expect the result to be 0. Here we expect the result to be 50, but we are adding a comment here. This comment is just used if an error shows up. It will be able to say the expected result was 50, but the actual result was 47. We have made an error here. And then it will add this comment to it. So it's just an extension of the error messaging that you can add. I think it's a bit clumsy, so I'm not using that one that often. But 2 options. You can add your own error message. Usually we are, for your queue, we are expecting you to have a class called queue test or something like this. And we are expecting it to have a number of test methods. That means methods annotated with test, and usually in each such one we are testing 1 or 2 methods from the queue class. So as ordinary methods, they shouldn't be too lengthy. You shouldn't be lazy and only have 1 test method where you're testing the entire queue. So your methods might be named test unqueue, test initialize, test remove, test different things. And then you are testing one or two methods from the interface in each test method. Exception testing. The mult method should raise an exception when the second argument is negative. It's a bit clumsy, well, not clumsy, it's much easier nowadays than it used to be. But what we are doing down here is that we are triggering an exception. We are using a negative second argument here, but we have an assert method that says assert throws. Here we are specifying, we are expecting an illegal argument exception to be raised when we are doing here. And here we are actually providing a lambda expression. A lambda expression that just executes this one. So this method assert throws has two parameters. It has, we are specifying what exception that we are expecting, and by providing a non-input lambda expression, we are providing code that will generate this exception in this case. Did it make sense? It's a bit strange. They want you to not insert the code. Well, this is their way for inside it. The second argument here is basically code that should be executed, and we are expecting it to generate an exception. So, yeah, this is new. In Java 5 that was released last year, they started to use a lambda expression. So when you look for the documentation, you might see that they are, in certain cases, using lambda expressions, but you are all by now very good in lambda expressions, are you? Good. Another example. Here I have a method called sort, similar to the one that I was discussing earlier, but here I have my own implementation of a method that sorts this array. It's called sequential sort. We will talk about the approach I'm using here, but for the time being, forget it. All we do here is that we are sorting this one. And the test idea is we should see if it works with an empty array, a singleton array, a few standard cases, and one large array. So, and the corresponding test case is called test sorting, annotated with test. I'm dropping here to save a bit of space, some small tests. But then I'm using one of my own methods, and this is private help methods. You will see that it's often quite handy. Rather than 50 times building up an array with different sizes and different values, you have one or two help methods that you can use to build up suitable input data. So here I have a method called random that takes a given size and a certain max, and it will produce a new array containing values between 0 and max. So up here I call this method and say, okay, give me a random array of size 100, and then I send it to my sorting method, and then actually I check that it is sorted, and I'm checking that this one is sorted by comparing them pairwise. If it is correctly sorted, then the next element should always be larger or equal to the previous element. So I'm iterating over them all here just to check that it's sorted. And I assert here that this is true. As long as it's true, nothing will happen. If we find two elements next to each other that are not sorted, it will raise an... when we are running it as a test, it will give an error. Here I create a much larger array containing 100,000 elements. I'm sorting it and I will run through it. It turns out that it takes about 15 seconds to sort 100,000 elements. But in general, we are looking at it from a JUnit perspective. I have a method called test sorting that I've annotated as a test, and then I'm building up different arrays, do something, sorting them, and then I check that they are actually sorted like this. Yeah. So this is what your test code will look like. A number of methods annotated with test, where you are testing a few things about, in this case, the myMath class to see that it works properly. You will also often have a few help methods that you are using to generate data for your testing. If we take a look in our imports, we have a bit strange import here. What is this? Have you seen this one before? Usually our imports looks like this. We are importing a class. What we are saying in here is actually that we are importing all the static methods in this class. So we are making all the static methods in the assertions class available. That makes it possible for us to just call them using assert like this. We could have taken this approach. We could have imported this class, not the methods, the class, and then we could have called them like this. But this is typical in JUnit. You don't want to have this assertions all the time. You just want to write it like this. So then we are importing the methods directly, like this. There are a number of assert methods. This is just a few of them, and they are easy to understand. Assert equals with 2 imp parameters. It will apply equals on these things to make you. If you send in 2 objects, it will apply equals to them to see that they are equal. Assert same are comparing them in this way. If we are comparing it in this way on objects, what are we comparing then?
We are referencing to the exact same object.
Yeah, we are basically comparing their memory address, and if they are the same, it means they are the same objects. Equals means we are applying the equals method and they are the same. Assert true, assert false, assert null, there are many, many more. I had another example, assert throws. I will later on give you a reference, a web reference to the documentation for the JUnit class. And you can take a look at this class, Jupyter API assertions, and you will see 20 or 30 different assert methods are available. I will show one more example. Both this myMath example and the intlist example are available in Moodle. We will test an implementation of this interface. So here I have an interface intlist with standard methods for a list, and I will and I have one implementation of it called imp. What is it called? It's called, we have a class intlist_impl that implements this interface, and I will try to test this list implementation. If you take a look at my test class, which is called intlist_test, usually when you are putting together a class used for testing, it should involve the word tests. The entry point to your program is often a class where we have inserted the word main to indicate that this is where the main method is. And often people are inserting the word test in the class names to indicate that this is a test class. We are testing the intlist implementation. We have a number of test methods. For example, this one tests the initialization and the size method. This one tests add and get method. This one tests the index of method. A number of these. I also have 2 methods up here that are tagged a bit differently. before each and after each, you will see that, I think it's, so this is my test class, a number of tests that I'm not showing here, but we have two methods before and after. And what happens when we are executing it? You are telling the tool JUnit to execute your test case. It will run through the test case, and it will take a look at all methods that are tagged in some way. If it finds a method that is tagged with before all, it will execute it first. Before all means this is the first method to be executed. If it then tries to identify methods that are tagged with before each and after each, it will also identify all methods annotated with test, and then for each test method it will run this code. It will run before each, and then a test, and then tear down. For each test method it will go through these steps. So the before each method is a bit of code that we are running before every test. The code annotated with after each is a method that we are running after each test. And then we have before all executed first, and we also have after all, it's the final method that is executed. Why do we have this before and after? Well, quite often we want to build up a scenario in some way. And then it's quite handy. For example, in before all, we can open a database, set up some prerequisite that we will use in our tests. And here in after all, we are closing down this database or network connection or something like this. It might be that we will always start to build a few lists of standard cases that we will use in all our tests. So then we have, in the setup method, we will have build a few arrays that will later on be used here, and down here we are removing this one, doing something with them. So methods annotated with before something and after something are used to prepare and restore data that are used in various tests. Did you get this idea? So if we go back to this overview of my int test list, it will start in this case to execute this one, then this one, and then this one, and then this one, and then the next one, and this. It will run through all this. It used to be in Java 4 that the methods here were executed in this order, but I noticed in Java 5 that it can be in random order. So you cannot expect this one to be executed before this one. They might come up in any order as far as I know. Yes?
What happens if you have several before all or after all?
I haven't tested it, but I guess it will complain or pick one of them. Why should you?
Maybe you want to have always like end with two methods?
Before all is preparation before testing starts. You do it once. And if you want to do more in this one, you extend this method. Yeah. So only one before all, or also only one before each. Yeah. Another example that is available in Moodle that is related to this lecture is an example called JUnit 5 demo. I have a number of methods here that I've tagged with before all, after, or before each, and they are just printing some information. But if you're running this program, you will see in what order they are executed. It will, if everything works, it will start by running this one, and then this one, this one, this one, this one, this one, this one, and then in the end it will run this one. But as I said, I noticed that in the new version of Java 5, they are not executed in the order they are stated here. It can be in any order. JUnit are using two Java features that can be considered as somewhat advanced. Annotations, they are the test before all. And we have something called reflection. We have earlier on used annotations, override. When did we use override?
When we extend a method.
Yeah, when we are overriding a method in a superclass. For example, when you are overriding the default behavior in the object class, the toString method. What was the purpose of including this one? If you're including this one, then the compiler will check that you're actually overriding something. So in general, the annotations are instructions used to different tools. In this case, it is an instruction to the compiler. Test here is used by JUnit to identify methods. Annotations, they're never executed. They're just tagging the methods or different parts of the program with different properties. Reflection is a word that relates to Java's capability to analyze classes at runtime. I will not go into detail, but you can do a rather fancy thing with reflection. For example, you can build your own class at runtime. Or as I'm doing here, I put together a method called invoke toString, and it just takes a class name. So you can call it with Java util date, for example, or something like this. What happens inside here is that we are saying, okay, give me a class for this name. And then we say, give me the method called toString. And then we are creating a new instance of this class. And then we are calling the toString method on this object. Over here. So if you provide a name of a Java class here, it will create an object of this class and call the toString method on it. This is called reflection. We are at the runtime analyzing a class to see what methods we have, and then we start executing them or something like this. And this is exactly what JUnit is doing. It takes your test class, it runs through all the methods, and it picks out those that are test methods, and it recognizes those that are before all and before each, and collects them, and then it starts to execute them in a certain way. So the way JUnit is working is based on reflection to identify these methods that are tagged. But don't worry about that. Here I have one example from my int list test. In this case, I'm interested in testing the add method and the get method. I'm testing the add method by the add method is used inside build. So when I call the build method here, it will build me a list that contains this one using the add method. And then I'm just checking, okay, the size should be 5, and I'm building another one, and I'm checking that the size is 10, and then I run through all these elements, and I check that in the first position we have 0, in the second position we have 1. I know what it looks like, so I can check that it looks like this. So when you do testing, sometimes students have a tendency to think that all the tests should be advanced or difficult. No, they shouldn't. We are building a list with size 5, then we are checking that its size is 5. We are inserting these elements, then we are checking that these elements are at expected position. So often the tests are very simple. We just do something with, and then we check the output is the expected one. Also, here I'm checking that the get method is throwing the expected exceptions. So I'm using the assert throws method. We are expecting an index out of bound exception, and I'm calling and I'm providing the code get element at position -8. It will of course generate an exception, and here I'm asking give me the element at position 123, which is outside the range, so it will also generate an exception. Yes?
So once you have verified that everything is correct and everything works with the test methods, what should you do? Like, should you comment them out or delete them, or
No, you should save them.
just leave them there?
Yeah. The idea is that we have complete test classes. Later on, when we make an update in our implementation, we just run the test one more time to see that everything works. So they are a piece of code that is just as precious or valuable as the ordinary code. People are storing them in the same way as the ordinary code. And the nice thing is that we have them there, we do some changes, and we can just rerun them all. The regression testing that I talked about, when we are testing after an update, then they run all the test cases. It usually takes a whole night to run through all the tests. But it's the final test before we are releasing it to the customer. We go through all the tests and try to run them one more time to make sure that it works. Once again, in this case we are testing the int list implementation, so I have a number of test generating methods. I have one called build that builds a method that builds a list with content that I know about. I know exactly what it will look like, and also I have another one that generates a random list. This one is used for the sorting testing. So quite often you will notice it yourself when you have in your test code created a queue and added 10 elements to it. When you've done this 5 times, you realize that I shouldn't do it in every test case. I should have a separate method building up a queue with 10 elements. Then you move it to a separate method. So this is what they are recommending. Companies that are using JUnit, they often force their software developers to take this approach. They are implementing a method, and then they write the tests for the method. And each test tests about 1 to 2 methods. So you have your code for the class that you are implementing, and you have another few windows related to the testing. You implement it and you test it. Basically, you don't need your main method any longer. We have used the main method to test our classes. You can just as well, or much better actually, use JUnit to test all your classes. So, getting started, I think most of you have JUnit 5 installed. I think you can take my test program, my example program from this lecture, insert it into Eclipse and see if you can run it. If you can run it, you have JUnit 5 installed. I will also show what it looks like. Here I have a test class. It's the one that I've been showing here, int list test. All you have to do is to right click here, go to run as, and then it will say JUnit test. Then it's switched over here. Here it turns to the JUnit result page or something like this. It says that we have been running 5 tests, we didn't have any errors. If we should insert an error somewhere, save, run. It will say here that I have run 5 tests and we have 1 failure. And it says down here, it expected 9. That was said. I said we expected 9, but it turned out that the actual size was 10. It's a tiny text. And also, if you click here, it will highlight the one which contains the error. So it's quite handy. You are developing it in JUnit in Eclipse. You have annotating them like this. You have the correct imports here. Then you are just running it as a JUnit test, and it will switch to the JUnit view and run it and present the result. We should fix this one. Back to no errors. One more thing. Let's go to the JUnit lecture. 5. Assume you would like to create a new test case. Then, as usual, you right-click here. You say new, and then you don't take a class, you take a JUnit test case. And then you are making sure that you are not using JUnit 4 or JUnit 3. The new version is called Jupyter. So we say we would like a JUnit Jupyter test. We give it a name, XXX, and we finish. It will generate an embryo of a class containing the correct assertions, and it will also give you a skeleton of a test in here. So, and if you take a look here, you will see that they are displayed slightly different, the tests. When you want to create your test, create not an ordinary class, create a JUnit test using this approach, and it will give you a good starting point for implementing it. JUnit should already be installed. Create a new JUnit test case, as I said, file, new, and then you select this one. Make sure to select JUnit Jupyter tests, then you get the JUnit 5 versions. I also suggest that you are downloading my JUnit example from this lecture and take a look at them. Basically, you will understand how they work. Look at the int list test, I suggest, how it works, and try to run it, try to insert a few errors in it, and then start working on the JUnit exercises. JUnit have their own website, and JUnit 5 is devoted to the new version of JUnit. They have a user guide, and they have a lot of things. JUnit is extremely popular. Many companies are using it. So Google on JUnit 5 and whatever you're interested in, you will find plenty of information. Make sure to search for JUnit 5. JUnit 5 was released last year. A lot of information is available for the older version, JUnit 4, and they are quite different. So a JUnit 4 approach will not work in JUnit 5. So make sure when you're Googling on things that you have something that solves the problem you're looking for using JUnit 5. We have 2 exercises related to JUnit in this assignment. Of course, you should write a test for the queue in exercise 1. And those of you who started with the circular queue in exercise 2, the VG exercise will be to write a corresponding test for this one. Have you started with a circular queue? Yes? No? Okay, it's a bit tricky. You often need to make a lot of errors before you make it work. Any questions? Okay, good luck with your programming. Next lecture will be next Monday, and it will be Tobias who is the teacher, because we will start with graphical user interfaces. Be kind to him. Yeah. See you.
Vad bra var det att det är meningen att jag ska implementera det här första exercise där. Nej, det här är klar, men ingen uppgift sen. Jag ska lägga på det står ju. All right.
Hi, sir.
Hi.
I want to talk about I want to talk about that like transfer credit. So I guess the Patrick Warburg has contacted you.
Who?
Yeah.
Who? But who contact? Who should contact me?
Yeah. I'm
Okay, but what program do you belong to?
I guess I'm doing like math.
Okay.
I guess applied math.
Yeah,